Alright guys, today we're going to be differentiating polynomial functions using the power rule. As you can see, we have a number of examples here on the right side. The first one that we're going to be looking at is y is equal to 3x to the fourth minus 2x cubed minus 4. So what we're going to do now is to do dy dx, which is to take the differential. And the simple thing to do is to use the power to multiply by the coefficient. Then we lessen the power by 1. So we're looking at 3 times 4 and then x to the fourth minus 1. Negative 2 times 3, x squared, x to the third minus 1. And the differential of any constant is 0. So 4 is 12. X to the third minus 6 x squared. So there we have it. Our differential, or what we would call d dx or dy dx, is equal to 12x to the third negative 6x squared. That's our first example. Let's look at another type. Alright, so let us look at the second example. Y equal to negative 5x cubed plus 5 over x squared. Again, what we're going to do is to write the 5 over x squared as a negative power. So we'd have negative 5x cubed plus 5x to the negative 2. And then the principle remains. We're going to use the power to multiply by the coefficient and then lessen the power by 1. dy dx is going to equal to negative 5 times 3, then x cubed minus 1. Sorry, x cubed minus 1. So plus 5 times negative 2, x to the negative 2 minus 1. And then from here, what we can do now is to simplify this. So let's finalize this. dy dx is equal to negative 15. That's negative 5 times 3, negative 15. X squared. 5 times negative 2, negative 10. X to the negative 3. So there we have it. dy dx is equal to negative 15 x squared minus 10 x raised to the third power. What if it never came like that? What if we saw something like a square root in it? How do we approach that? So let's look at example number 3. Y is equal to 10 the root of x minus 4 over x cubed. We're going to rewrite this simply using powers, removing the square root. 10x and the square root means a half power. So 10x to the half. And then we represent the cube as a negative power. So y equal to 10x to the half minus 4x to the negative 3. At this time, we are now able to take dy dx. A half times 10, and then x to the half minus 1. Negative 4 times negative 3, x to the negative 3 minus 1. Now let us see if we can simplify. We could simplify the 2 and the 10. So 2 into itself 1, 2 into the 10 5. Now let us rewrite this. dy dx is equal to 5x raised to the negative a half, because a half minus 1 is going to give us a negative a half. Negative 4 times negative 3, that's positive 12. And then we have x to the negative 4. Negative 3 minus 1, that's negative 4. So there we have it. dy dx is equal to 5x to the negative half plus 12x to the negative 4. There are times when we have two binomials multiplying. We could also turn this into power. So we could apply the power rule. So let's look at another case. Number 4. Y is equal to, open bracket, 3x minus 1, close bracket, open bracket, x plus 2. So what we could do is to simply expand this. Whichever way you can expand it. If you want to foil it out, if you want to use, your regular stuff that you use, it's okay. The main thing is we're going to multiply this bracket by the next bracket. So I'll apply the file. So as you could see, 3x times x plus 3x times 2, negative 1 times x, negative 1 times 2, and then we'll simplify this. Y is equal to 3x squared plus 6x minus x minus 2. And then at this stage, we need to simplify this. It can work, but we can simplify this to make it works a little quicker. So 3x squared plus 5x minus 2. Now everything is written, in a nice way. So now we can apply the dy dx. 2 times the 3, x squared minus 1, or the power of 1, plus 5 times 1, and x to the 1 minus 1. And then you could say x to the 1 minus 1, then that's basically, x to the 0 power, which is 1, so we'll see that that's just 5. So let's look. dy dx is going to give us 6x to the first, or you just say 6x. So you could rub off the first power if you want. So basically that's 5x raised to the 0, but at the same time, anything raised to the 0 power is 1. So basically that's 5 times 1, and 5 times 1 is just basically 5. So naturally, as you could see, the differential is 6. The differential is 6x plus 5. Okay, let's look at the last example. All right, the last example. Example 5. So y is equal to negative 6x squared plus 2 all over x cubed. We're going to rewrite this. So in rewriting this, what our intention is to get everything in a power, getting that division part to a minus power. So we're looking at negative 6x squared plus 2 multiplied by x to the minus 3. Now, what we're going to do now is to distribute x to the negative 3 inside the bracket. So we still would be simplifying this. So y is equal to, so negative 6 x to the second plus minus 3. Because when you multiply similar letters, you add their powers. Then it's going to be 2 times x to the negative 3. One last simplification. Y is equal to negative 6x to the negative 1 plus 2x to the negative 3. So at this time, we have some nice powers there, so we can simply take our derivative, dy dx is equal to the negative 6 multiplied by the negative 1. So that negative 6 times the negative 1, then x to the negative 1 minus 1. It's going to be positive 2 multiplied by negative 3, then x to the negative 3 minus 1. So let us finalize this. dy dx is equal to 6, positive 6, x to the negative 2, negative 6, x to the negative 4. So basically, there you have it, guys. We just did some differentials using the power rules, differentiating some polynomials. Just an